Today in PSAT prep, we are going to review factoring quadratics by grouping. And the reason why we're doing that is because it's going to help us solve a problem that looks like this. So let's go back to Algebra 1 when you first learned about factoring by grouping, and your teacher is asking you to factor quadratics, and they gave them to you in a way such that there were 4 terms in the problem. So here's an example: x squared plus 3x minus 2x minus 6. So what you do is you group the first 2 terms and you think, hey, what can I factor out of the first 2 terms? And I know that they're both divisible by x. And when I divide them by x, I get x plus 3. That's what's left over. And then these next 2 terms, what can I factor out of both of them? Well, I can take out a negative 2. And when I divide both terms by negative 2, I conveniently get the same thing, x plus 3. And that's factoring by grouping. So when I factor out a term, they both conveniently have the same common leftovers. And then what you do with the x and the minus 2, you put them in their own little parenthesis chunk. And then what they have in common is in their own little parenthesis chunk, and that is factoring by grouping. And then your teacher actually wanted you to solve them, because this was actually a set equal to 0. So when you to solve it, you set each little parentheses equal to 0. That's called the zero product property. And if I want to solve x minus 2 equals 0, I just add 2 to both sides. I get x equals 2. To solve x plus 3 equals 0, you just subtract 3 from both sides. You get x equals negative 3. Okay, let's do a slightly harder one. Again, there's 4 terms going on, and it's a quadratic, so they're wanting us to solve it by factoring by grouping. So the first 2 terms, what's the greatest common factor? What's the biggest thing I can factor out of both, divide into both? And hopefully you know that's an x. And when I divide by x, I'm left with 5x plus 2. So here, what's the biggest number I can factor out, or the biggest thing I can factor out? And it is, they're both divisible by 3. So when I divide by 3, I conveniently get 5x plus 2. So they're the same, so you take the thing in front, x, and the plus 3, you put them in their own little chunk, the 5x plus 2, and the 5x plus 2 just becomes 5x plus 2, and now it's completely factored. And then your teacher asks you to solve them, so you set each little chunk equal to 0. If I solve the first chunk, I subtract 3, I get x equals negative 3. If I solve the second chunk, I subtract 2, and then divide by 5, I get x equals negative 2/5. Okay, let's do another one. 6x squared minus 4x minus 15x plus 10. Again, 4 terms. It's a quadratic. Looking at the first 2, what can we divide into both of them? Hopefully you realized it was 2x. So when I divide it by 2x, I'm left with 3x minus 2. What can I divide into both of these? Well, I'm going to have to take out a negative because the first term's negative. So negative 5. They're both divisible by negative 5. When I divide by negative 5, I get 3x. When I divide by negative 5, I get negative 2. Look, they're the same thing, 3x minus 2, 3x minus 2. So you just take these first 2 chunks, 2x minus 5, give them their own parentheses. And then again, your teacher wanted you to solve them, so you set each factor equal to 0. Add 5 divided by 2, I get x equals 5/2. Add 2 divided by 3, I get x equals 2/3. Okay, one more. And this one is the SAT question. So I see I have 1, 2, 3, 4 things going on. I'm going to start by just distributing the negative and the x through, and I'm just going to write it as my 4 terms: 64x squared minus 16ax minus 4bx plus ab. I'm going to ignore the equals 0 because that's a given right now. Okay, so my first 2 terms, what can I factor out of both of them? They're both divisible by 16. They're both divisible by 16. You can use a calculator. They're both divisible by 16 and x. So when I divide by 16 and x, I get 4x minus a. And then the second chunk, they're both divisible by just b. So when I divide by b, oh sorry, negative b, because it's a negative term. The first one's negative. So I get 4x, and when I divide it by negative b, I get negative a. And you'll notice, hey, look, the terms, they're the same. So I'm going to write 16x minus b times 4x minus a. And again, if I wanted to solve them, because it says solutions right here, I want to solve it. You set each little chunk, each little parentheses equal to 0. So when I solve it, I add b to both sides, divide by 16, so I get x equals b over 16. Add a to both sides, divide by 4, I get x equals a over 4. Okay, and you think, man, this is a really long problem. Well, hopefully you did the other problems really fast so you can spend some time on this last problem. And it says, hey, the sum of solutions. Sum means I'm going to add them. So when I add these two, my sum of solutions is going to be k times 4a plus b. Okay, if you don't like fractions, which I know a lot of people don't, just multiply everything by the biggest number. That's how I usually start. I'm going to multiply everything by the biggest number. When I multiply by 16, it cancels out. I'm left with just b. When I multiply this by 16, well, there's a 4 on bottom, so 16 divided by 4 is 4. So I'm left with 4a. And then when I multiply this side by 16, well, it doesn't cancel out, so I'm just going to put 16 in front. So again, all I did was I multiplied everything by 16. That's just an algebra skill. I'm solving my equation. And, well, I notice something looks familiar. Let's see. This has a 4a plus b. This has a 4a plus b. Like if I just flip them around, it's the same thing because I'm just adding. So I'm going to divide both sides by 4a plus b. And when you divide something by itself, it becomes 1, not 0, 1. And it goes away on this side because I divided. And again, I'm solving for k, so I can solve for k by dividing by 16, and I get k is 1 over 16. So hopefully this helped you understand how to solve this problem. I'm sure there are other ways to solve it using some tricks and stuff, but as long as you've taken Algebra 1, you do have the ability to solve this problem.